talking too much. You have to go back to your seats if you can't handle it. On the very, very top, let's remind ourselves the differences about our two types of exponentials. We have an exponential growth, we have an exponential decay. Just at the very top, we're going to do a couple little notes. Do you remember what the base looks like if we have an exponential growth?
I don't have any room on mine.
Sure, if you have space on the bottom, do it on the bottom. Okay, do it on the bottom then. What does the base look like if we have an exponential growth? Well, the graph goes up, but what about the base in the equation? I'm looking for a specific type of number. Your option is 1 or greater than or equal to 1 or a fraction. Which type would be a growth? When the base is a fraction or a number greater than or equal to 1? Yeah, that would be a growth. If we have a fraction as a base, that's when we get a decay. So on the top or the bottom, I guess we have more room on the bottom. Write this, please. If we have an exponential growth, an example of an exponential growth is y equals 4 to the x. The base is like the cheerleader, the base holding up the exponent. So in this case, the base is 4. Since 4 is greater than or equal to 1, it's going to be a growth. And we look at the absolute value of the base, if it's greater than or equal to 1. We get an exponential decay if the base is a fraction between 0 and 1. Notice it doesn't have equal to. It's between 0 and 1, but not including 0 and 1. We have the same shifts that happen on exponentials as we do with quadratics and absolute value functions and linear functions. Hey, Dylan, we'll use your phone later. We've talked about this all term 2. When we have a multiplier a to the function, who can tell me some things that a does? A does potentially up to 3 things. What is 1? It flips it. If it's negative, the graph flips. What else happens? Well, it's called a transformation. Translation is a shift. This is a transformation. Okay, put the crackers away, please. Put them away, please. There are 3 things A does. We wrote these on our notes last class. This shouldn't be new. When A is less than 0, it flips. We've written these so many times this term. What happens when A is the absolute value of A is greater than, not equal to, greater than 1? We did this last class. You only gave me the first one, so I'm going to get someone else. What happens if a multiplier is greater than 1, like 2 over 1? Rise 2, run 1. Rise 2, run 1. It's a vertical stretch. The arms come in. It gets steeper. It gets steeper. Ooh. And the other option is if it's a fraction between 0 and 1. A fraction like 1 over 3. You rise 1, run 3. Rise 1, run 3. What happens to the arms of this one? Vertical compression. You guys need to get these memorized. Vertical compression gets wider. The h and the k does the same thing as it does in all the other functions. H is up here in the exponent with the x. It's within the exponential. Yep, horizontal shift. What does the plus k after the exponent do? Vertical shift. Horizontal shift, vertical shift. Equal what they're saying for how we shift.
Horizontal shift.
Is that the same or the opposite?
Same.
We say opposite, and this one is
Same.
same. Has the same properties that we went through on all of the functions last class. Okay, there's one more thing that we need to remember. Any non-zero number raised to a 0 is what? Like 4 to the 0 power, 7 to the 0 power, negative 1 million to the 0 power. What does that equal? 1. Yeah, 1. So any non-zero real number to the 0 power equals 1. Okay, so put some examples. That's important for our graphing. Speaking of graphing, everyone will need a calculator. If you don't have a calculator, come get one, please. Yes, Laura? Can you what? You can write it on the... Yeah, that's fine. Everyone needs a calculator. Hustle, hustle, hustle. I like to get to the game. Nico, write your seat. Okay, I'm going to flip through the worksheet, so make sure you have all those written down. Don't be throwing things. Sounded like you hit it pretty hard.
Not even like that.
Okay, on the worksheet, we're going to start with number 1. Whoa, hold on. Hold on. Clear off. No cheating. Clear off. Okay. Better. Okay, turn around, please. Okay, hurry and ram down. What we're going to do on number 1, after we turn forward, is identify A, H, and K, and decide if it's a growth or a decay. Can I switch back to this page now? Okay. First, I would like to identify the base so we can decide if it's a growth or a decay. Fingers in the air, please. What's the base of number 1? Fingers in the air. I'm not asking you to say anything. I'm asking you to show me. Fingers in the air. What is the base? The base holds up the exponent. I do not see the correct answer yet. There we go. Isabella has the correct answer. Yeah, 1/4 is a multiplier. The base holds up the exponent. The base is 8. Okay, based off of what I just told you and reviewed on your notes, so you should have written down, the base is a number greater than or equal to 1, so is it a growth or is it a decay? It's a growth. So when we graph it, we should make sure it's growing. Right, growth. That's the first thing you should identify. The base and determine if it's growth or a decay. There will be a couple of these on your test next time. It's not a full test, it's just a short little mini test for 50 points though, which still 50 points of test points on your grade, so it's still important. Now we're going to go through and list A, H, and K and explain what they do. Fingers in the air, please. What is A? And in case it should be on your notes, but in case you've forgotten, I have it written over here. A is the multiplier. Fingers in the air, what's the A? Thank you. Fingers in the air, what's the A? No, the base is 8. A is not the base. What's the multiplier? The multiplier is A. Should be 1/4. Okay, we just wrote down what fractions that are multipliers do to the graph. Elizabeth, can you tell me what the 1/4 does to the graph? It's a fraction between 0 and 1. Yep, because you go up 1, out 4. Vertical compression. It's going to get wider than the original parent function. Okay, next, what is the value of H? What is the number up with the x in the exponent being added or subtracted to the x? Fingers in the air, please. What's on number 1? What number is being added or subtracted to the x? They're all here. Okay. I don't see it correctly yet. What number is up here in the exponent with the x?
Oh.
Nope. Is there a number up here with the x being added or subtracted? No. So that number is 0. That means there is no horizontal shift. Okay? Please tell me what k is. K is after the exponent. What number is out here after the exponent? You see an 8 where I'm pointing? Wow, you have really great vision. That's not an 8, is it? What's out here, Mikla?
0.
0. There's nothing there. So there is no vertical shift. Okay, so we're going to start graphing this. The first point we're going to do by hand, and the rest we're going to have the calculator do them for us because they're going to be decimals. We want to know, don't get a calculator yet, we're doing this by hand, so put the calculators down. We know anything to the 0 power is 1. So we want to make sure the exponent is 0. So I'm going to plug in x equals 0. So I have 1/4 times 8 to the 0 power. Okay, Colby, what is 8 to the 0 power? No. We just wrote this down. It's 1. 1/4 times 1, which is a nice pretty 1/4. So we have a point on the graph. We plugged in 0. We got 1/4. Would you plot that on your graph? 0, 1/4 is really close to the x-axis. Oh, calculus folders I've put over here in the basket so they're ready to go home. All right, grab your calculators, please. They're in the basket. Look for the red folders. I'm going to show you a way for your... Oh, right. Oops, that's the wrong button. A way for your calculator to get the rest of the points for you. The point of this lesson is to not learn how to do x, y tables. The point of this lesson is to learn how to graph the exponentials. So we will let the calculator do the rest of the work for us. Open them up, please. Colby, you need to come back to your seat. Because you're in the wrong seat. And still talking over there. So please come back to your right seat. Thank you for moving. All right, would you go to y equals, please? Clear out anything that's in there. And we're going to type in our function. But any fractions we type in have to be in parentheses. So put parenthesis 1 divided by 4, close the parenthesis, times 8 to the x. Like that. Okay, Mikla, open up your calculator and type that in, please. In the back, everyone got that? To make sure everyone's on the same window, go to zoom number 6, which is Z standard. We want the zoom to be standard. Open up your calculator. Go to y equals and type this in. Caret is right above the division sign. Okay, so if you go to zoom standard, it should graph on a normal coordinate plane, but we have to graph that thing by hand. So look above the top 5 buttons. Do you see anything there that's table to help us get some points? Do you see anything that says table? Second graph, this one. Isaiah Cooper. Shush. So second graph. Now we learned one of the points that's important is 0 and 1/4. And look at our graph. It goes all the way up to 20. So I don't want to graph anything that says error. That's standard. That's scientific notation. But I do want my y's to get close to 20. Oops, if I go to 3, it's way off the graph. 128 is not on my graph. So I'm going to graph these decimals starting at -2 to +2. Grab your pencil, -2, comma, 0.003, which is just a microscopic hair above the x-axis. Then your calculator gives you another one. -1, comma, 0.03, which is another microscopic hair just above the x-axis. And then we've already done 0, 1/4. Is 1/4 the same thing as 0.25? Yeah, it's the same thing. Now we have to graph 1, 2 and 2, 16. 1, 2 and 2, 16. Look how much higher that point is. Exponentials grow faster and faster and faster. So you go up and up faster and faster each time. And then we have a horizontal asymptote here. It's an end behavior asymptote that we get closer and closer to horizontally and never actually cross. That's our graph for the exponential growth, and it was a growth as we predicted it to be. Okay, draw on the dotted horizontal asymptote, please. Okay, you don't need to be touching your calculator anymore. Graph this, please. Slowly. You use your phones later. Number 2. Look at number 2. Is number 2 an exponential? Well, actually, let's find the base first. Look at your worksheet on the base. Hold it up in the air. What is the base for number 2? What is the base for number 2? Hold it up in the air, please. What about you boys? What's the base for number 2? Just 1? I don't think it's just 1. Do you see the guy holding up the exponent? There's the exponent. So the base has to be half, 1/2. Okay, so is it a growth or a decay? Is it going to grow or is it going to decay? Decay. Fractions are getting it smaller and smaller and smaller. So it's a decay. Write that on your paper. This one is a decay. Just want a marker. Okay. Next, we list A, H, and K. Fingers in the air. What is A? What is our multiplier A? Thank you. Oh, that's the base. What's the multiplier A? That's in front of the base. 3. All right, Alex. 3 is our multiplier. Can you tell me what that does to the graph? It's greater than or equal to 1. Vertical compression or vertical stretch? Not for 3. So we go up 3, over 1, up 3. So the other one is vertical. Yeah, if it's a big number, it's going to stretch. If it's a small little fraction, it's going to compress. So vertical stretch by a factor of 3, which means it's going to get steeper faster. Okay. Fingers in the air. What number is being added or subtracted to this x? Because that would be in the h position. What number is up here in the exponent? Good. That's being added or subtracted to the x. It is a 0, because there's not one there. So that means our horizontal shift is none. After the exponent comes k. What number is being added or subtracted after the exponent? Good. Laura, what do you have? Good. Vertical shift is also none. It's not always that way, but for these two it has been. Okay, so our next thing is we need to find that one point. We find one point that is a nice, easy point to plot. Oftentimes with exponentials, the other points are just really nasty decimals. But there is one good point we can plot. And that point is when the exponent is 0. So we're going to plug in 0. 3 times 1/2 to the 0 power. Doing exponents first, because that's what we do with, please excuse my dear Aunt Sally, steps in, what is 1/2 to the 0 power? Good. 1. So we get 3. Tyson, can you tell me the ordered pair, that point that we found because we plugged in and got 3? What? What was the number we plugged in for the exponent? 0, and then the output at the end was 3. Okay, put that on the graph. 0, 3, it's right there. See, that's a really nice number to graph. Now we're going to use our calculator to get the other ones because there are going to be some decimals, and I don't want to have to figure out these decimals by hand. That's kind of awful. So, remind me, how do I do this with my calculator? Go to y equals. Oops, I went to the wrong thing. Clear out the old stuff. You boys in front should be typing this. 3 times. What do I have to put around fractions? Parentheses. 1 divided by 2. Close the parentheses. How do I do an exponent? This caret, it's right here, right above the division sign. If you can see where my finger is, right above the division sign is the caret. X. And then how do I get that list of points? Second table, or that graph button, second graph. Now, look at my graph. What's the highest y value that I have in my window? I'm circling it. What is it? 20. So, I want my window. Sometimes you have to scroll up and down. I definitely don't want to graph 192. You scroll up and down until you have 20. So 24 is probably as close as we can get. So that's all of these points listed are the ones I want to graph. And do we actually have 0, 3 as we worked out? Did that come up here? Yeah, it should come up. So -3, 24. That's like somewhere about there. -2, 12. -1, 6. And we already plotted 0, 3. Dylan, please make sure you plot these. 1, 1.5. And now we're going to start running into those decimals. The smaller and smaller you get, the more decimals you get. 2.75 and then 0.375. Would you draw in your asymptote, since there were no vertical shifts, our horizontal or end behavior asymptote is right along the x-axis. So when you draw the curve, your curve gets closer and closer. Oops, I missed that. My shadow was in the way. I couldn't see. Let's do it this way. Get closer and closer, microscopically closer to that asymptote without touching it or crossing it. Is it a decay as we predicted? Yeah. Any questions on number 2? Do you remember these from 9th grade?
Yes.
Good. Okay, I'm going to move my calculator over here. Let's look at number 3. What's the first thing we need to identify? Good, the base. Put them up in the air. What is the base? The base is holding up the exponents. Boys in the front, hold it up. What's the base? Are you sure? The base. Make sure it's not a. It's the base holding up the exponent. Dylan, what's the base? Thank you. 3. Okay, so because of that, is this a growth or a decay since the base is 3? It's a big number, right? It's not a little fraction. Big number, it's going to be a growth. Every time you should identify that at the beginning. Colby, write it down. Okay, Isaiah Nang. After I've identified the base, what's the next thing we're going to start looking at? Thank you. A, H, and K. All right? Fingers in the air, what is A? What's A? 1/4. 1/4. Alrighty, is that going to be a stretch or a compression vertically? Compression. Vertical compression, meaning it's going to get wider than the regular y equals 3 to the x graph would have been. Fingers in the air, what is H? That's the base. What is H? What is H? Nope, H should be in the exponent. It's -1. Now this time we have 4 words. Horizontal shift, -1 if this is 0, -1's normally that way. So what are we going to say? Instead of left, it is right 1. K is after the exponent, after the function. Well, -1 is in the exponent. After the exponent's over, what's out here? 0. So that's a vertical shift, none. Which means when there's no vertical shift, that means our asymptote is still here on the x-axis. That asymptote changes when we have a vertical shift. Do you have everything written down on yours that I have on mine? Is that an excuse? Find one. Find a pen or something. Alrighty, we need 1 point. But we want our exponent to be 0. This time, if I put in 0 -1, is that going to give me 0?
No.
No. What number -1 is 0?
-1.
Positive 1. So we want to plug in +1 because there was a horizontal shift. Because I want the exponent to be 0. 1 -1. So I get 1/4 times 3 to the 0 power. Which is what, Elizabeth? 3 to the 0 power is 1. So we get, oops. That's a 1 times. So we get 1/4. This is a point on the graph. Aria, what would the point be? What's the x we plugged in and what's the y we got at the end?
0 and 1/4.
Except for this time we changed it. We plugged in 1, 1/4. And we chose 1 so that the whole exponent would be 0. Because 1 -1 would be 0. So there was a shift this time. Okay, so find 1, 1/4. It's right there. Then we use our calculator to get some more points. And we make sure it's a growth, because that's what we wrote at the beginning. Okay, Jeff, what do I do? Y equals. Now the 1/4, how do I type in 1/4?
1.
Thank you. Thank you. Excellent. Divided. That's how we do fractions, is parentheses and division. Okay, times 3 to the x -1. Notice I'm putting parentheses around x -1 because there's 2 things in the exponent. I need to group them together. So put parentheses around the x -1. And then go second table. Again, I want to see y is up to 20. Again, I put parentheses around x -1. Now my y's right now, the way my window's set up, I only see a y up to 2.25. So what do I do if I can't see all the way up to 20?
Roll up.
Scroll up or down? In this case, I think it would be down. And, oh, there's my 20. I'll put that at the bottom. So now I can see the 20. I would graph all of these points. Okay? And do we actually have 1 and 1/4? Yep, it's right there. Okay, plot those points. -1 and 0.02 is really, really close to the x-axis. So is 0, 0.8. Each of these should get slightly higher as we go because it was a growth. And then you should start getting higher faster, more rapidly. 6.75 and 5 is 20.25, which we can graph. It's just right above the axis. Now when you graph the curve through it, make sure it doesn't... Oh, come on, man. Catch up, please. Make sure it doesn't touch or cross that asymptote. We're going to graph one more on the back side. I think number 7 is the one I want to do. And then we're going to go to our game for the review.
Yes. Yes.
Uh-huh.
So all other classes are saying Cooper.
Okay, get those plotted. Okay, flip over to number 7. There will be a couple exponentials on your test, but the shifting is the same as the other functions, the absolute value functions, the quadratic functions. They all have the same properties. I don't know why it's so dark. Here we go. It's a little better. Okay, first, Omar, what do I identify first? Growth or decay? What would you say on this one? A growth? Why would you say growth? A 5? Now is the 5 the base or is it the multiplier? In this case, 5 is the multiplier. So the base is actually 1/2. So if we have a little base, is it going to be a growth or a decay? 1/2 is a little base. Is that going to be growth or a decay?
Growth.
Growth gets higher, higher. Those are bigger numbers. Decay are smaller numbers, right? Yeah? So if we have a fraction, that's a decay. Then we need our A, H, and K. Fingers in the air, please. What is A? Fingers in the air, please. What is A? A. It goes in alphabetical order. A, B, H, K. It is 5. Okay, Aspen, can you tell me what the 5 does to the graph? Not Aspen, sorry. Miriam. Aspen's not even here. Miriam. Good, because it's a bigger number, right? Vertical stretch. Okay, the base is 1/2. Fingers in the air. What is the H? That's up in the exponent with X. What's up in the exponent with X? 1. Okay, who can tell me 4 words that explain what the 1 does to the graph? That's not 4 words. That's 3 words, so you need one more. Horizontal shift. It says plus, so we're going to go left 1. Good. Horizontal shift left 1. Because that's opposite. After the exponent is same. What numbers are k? -1. Okay, someone else. Who can give me 4 words that explain what the -1 does to the graph?
Vertical shift.
Shift, vertical shift.
Right.
Vertical is either up or down. Those are your only options.
Down. Down 1.
Opposite, same. This is same. So we go down 1. Yes? You're just going to say that? Vertical shift down 1. Okay, so what this means is a few things change. Horizontal shift left 1. Justin, put that away. Horizontal shift left 1. Usually, we're graphing around the y-axis. We have a horizontal shift, so now it went left 1, so I'm going to pretend this is my new fake y-axis. I shifted it left 1. AJ, you too. Vertical shift down 1. Normally we have an asymptote at x. But going down 1, I'm going to put my asymptote right here. This is my horizontal asymptote. HA, sometimes we call it. Horizontal asymptote. So I've shifted my axes left 1, like you said, and down 1, like you said. Now, the question is, what would make this exponent 0? What number plus 1 is 0? -1. So that's the number we want to plug in. Y equals 5 times 1/2 to the -1 plus 1 minus 1. You do your exponents first. And we get 5 times 1/2 to the 0, which is why we choose this one. Because anything to the 0 power except for 0 itself is 1. 5 times 1 minus 1, which is just 4. So we plugged in -1 and got 4. Notice -1, 4 is on my green dotted axis because I shifted it over, so it should be on that axis. And we just need some points and we're done. Plot the points and you're done. So one last time, go to your calculator. Go to y equals. Make sure you put parentheses and use division around that fraction. Boys in front, please type this in. X plus 1. What do I have to put around x plus 1? You have to put parentheses if there's multiple parts. And then close the parentheses before you subtract 1. Like that. Then go to table, get the points, and plot them. Again, look at my graph. I go up to 20. Can I see 20 on here where the window is right now? I only see 4 and -0.9. So I'm going to go up until I find that 20. Oops, 39 is too high. Well, there's a bar above it, which is 20. Okay, and these are the points I would graph. And we make sure it's the decay as we said at the beginning. -3, 19, I guess was right there. -2, 9, that one's already done. 0, 1.5, 0.25, smaller, oops. -0.375. This is the first time we've dipped below the x-axis. Why do we get a dip below the x-axis this time? Because there was a -1, a k. What does the k do to the graph? Vertical shift, and we had vertical shift down, -1. That's why our asymptote is lower, so we can dip below the x-axis. Okay? Any questions on graphing? You're going to have a couple of those on the test. Yep. Yep. Nope. Alrighty, we're going to do a game for our review. Your homework tonight will be to finish the exponential shifting that's already in the packet you already have, and this test review. The test is next time, so make sure you do the test review. Yeah. I can't today after school. We don't usually have it on Fridays, but there might be. Okay, well we have 8 math teachers in this building, so there might be one that's available. Unfortunately, I have something right after school I can't stay for. Okay, would you please put your paper away and pull out a new piece of paper and your cell phone? I won't take it if you are doing what I asked you to do and not something else.